everyone, we're going to find the solution set for each rational inequality. These are the two problems we're going to do, so we'll get started with the first one. The first thing I'm going to do is move the 1 over to the left side by subtracting it from both sides of the equation and setting it to 0. So what I have to do is find my common denominator, and to do that, I want this denominator to be x minus 2, so I'm going to multiply the numerator by x minus 2. So basically this just equals 1, and that gives you your common denominator, and you get x plus 4 minus x plus 2, so we get 6 over x minus 2. And again, we want this to be negative or equal to 0. So the only thing, we don't have any zeros, but we do have f is undefined at x equals 2. Therefore, if you do a little number line here, and we have 2, we want intervals from negative infinity to 2. That would be this side of the graph. And then we're also going to check on the other side of, remember this graph has a vertical asymptote at x equals 2, because that's where it's undefined. So then we're going to go to 2 to infinity, and then just choose numbers. And the numbers I chose were 0 and 3. Then I plug it into my f of x. F of x was x plus 4 over x minus 2 minus 1. So I'm plugging these values in, and I got negative 3, and I also got 6. Well, negative 3 is negative, and 6 is positive, and we want this to be, it's a non-strict inequality, because it can equal 0, but we want it to be negative. So we're choosing that interval. So our solution set is x such that x is less than 2. It can't equal 2 because if you plug in 2 in here, that gives you your undefined. You can't divide by 0. Alright, the next one we had is very similar. So I'm going to go ahead and move the 2 over. So I'm going to subtract 2 from both sides. And so this is our new inequality, where it's the same. I just moved the 2 over. Now I want my common denominator to be x plus 2 for both. So I want this to have the x plus 2, so I'm going to write 3x minus 5. It already has the correct denominator. Minus 2 times x plus 2. And simplifying this, we're going to get x minus 9 over x plus 2 is less than or equal to 0. And I have a 0. You set the numerator to 0. And that gives you a 0 at 9, 0. And also we set the denominator to 0 where f is undefined. And that's going to be x equals negative 2. So if I do a number line here, I'm going to go from negative 2 to 9. So the intervals I'm going to choose are this one, negative infinity to negative 2. Then I'm going to choose this interval, because we want to know how the graph is behaving in between these key points. And then from this one, it's going to be 9 to infinity. Excuse me. And Our function is 3x minus 5 over x plus 2 minus 2. And we want this whole thing to be negative or equal to 0. So choose some numbers in the intervals. I chose -3, 0, and 10. You plug in your values in your x's, and I got 12, -4.5, and 1/12. And all we care about is if it's positive or negative. This value is positive, this value is negative, this value is positive. Well, we want negative, so I'm choosing this interval here. So our solution set is all x such that x is in between -2. It can't equal -2 because you can't divide by 0. But it can equal infinity, or this would be 9 here because we're using this one, because we can equal here. This is a non-strict inequality. And that's all. Thank you. Have a nice day. Bye-bye.